In this video, we're going to look at propositions and truth tables. And so a proposition is a declarative statement that can be classified as either true or false, but not both. So let's take a look at some possibilities here. Which of these are propositions? Washington, D.C. is the capital of the United States. Study more. There's 6,000 people in New York. Who is the president? And x minus 7 equals 12. So we're going to look at these and see which, if any of these, are propositions. So let's look at the first one. Washington, D.C. is the capital of the United States. Remember, it's something, proposition, something to be classified true or false, but not both. So Washington, D.C. is the capital of the United States. Again, even if you didn't know whether or not Washington, D.C. was the capital of the U.S., this statement would be a proposition because it's going to be either true or false. Either Washington is the capital or it's not. So again, it doesn't matter what the answer is. And even if you don't know the answer, the question is this something could be classified as true or false? And the answer is yes. So for this first one, the answer is yes. This is, in fact, a proposition. So let me say it down here. A is yes. And how about B, study more? So that's really a command. That's not like a proposition, not something you can say that's true or false. So that one is no, that's not a proposition. There's 6,000 people in New York. Once again, this is true or false. Again, you don't have to even know what the population of New York is. Actually, it's certainly at least 6,000. So this would be a true statement. There are 6,000. In fact, there's millions and millions more. And you could even clarify that if you want to. You could say New York City if there is some question as to what you're referring to. So there are 6,000 people in New York City. And again, even if you didn't know the answer, if you didn't know how big New York City was, it's something though could be classified as either true or false. So this is yes, a proposition. And who is the president? That's, you're not saying that any particular person is president. You're asking who is the president. That's not a true or false statement. That's actually a question. So that one is no. And then finally, x minus 7 is 12. Now, if we said, 6 minus 7 is 12, that could classify as something true or false. It actually would be false. Or if we said what 19 minus 7 is equal to 12, we'd classify that as true or false. That'd be true. But we have this unknown x. This really isn't a proposition because it doesn't even have a value for x. So this one would be no, because we can't classify that as true or false unless we actually have a value for x. So you can kind of see what a proposition is. Something could be classified as either true or false. And then we have compound propositions. These are combinations two or more propositions. And so let's give an example. Geneva is a college. And it is in Beaver Falls, Pennsylvania. And so this has two propositions. Geneva is a college and is in Beaver Falls, Pennsylvania. Now you have to kind of know the context. Geneva is also a city in Switzerland. And so you could say with Geneva, you have to kind of know from the context talking about the Geneva here in Beaver Falls. So Geneva is a college. That's either true or false. And it's in Beaver Falls. That's either true or false. Now, the whole statement is true if both propositions are true. Because they both have to be true because it's saying and Geneva is a college and is in Beaver Falls. Now we could write that a little bit differently. Geneva is a college or it is in Beaver Falls, Pennsylvania. Now this time, because we have the or here, this statement is going to be true if just one of these propositions is true. If it's a college or it's in Beaver Falls, it could be some other institution in Beaver Falls. You know, it could be a club in Beaver Falls, for example. So it would be possible that that's not true, but it would be in Beaver Falls. So if either one of these is true, because it says or, then the statement is true. So this is true if either uh, if either Geneva is a college and or Geneva is in Beaver Falls. So again, because of the or, if one of them is true or they're both true, it could be and or, then the statement would be true. Now, later on, we're going to use letters to represent propositions. Usually, P, Q, R are used to represent propositions. So in the two statements up above, we sort of have them, they're kind of both the same. P, we could call Geneva is a college. And Q, Geneva is in Beaver Falls. So a lot of times we're going to work with these. We'll just work with, say, P and Q as we kind of evaluate these propositions. Now we're going to, again, be working with this and or and some other things here in a minute. And we're going to put some symbols together. So some symbols that we're going to use. We're going to use this for not. If you're using computer languages, some computer languages use this symbol for not. And we're going to have this for and. We're going to have this for or. Now remember, if you work with sets very much, remember the symbol for intersection is sort of an upside down U. And remember, intersection sort of means and if something's in both. And union means something's in either set. and remember it was a U. Here we have like a V. Again, when we say or, we're really meaning and or. So, but we'll look at this in a minute here. Now, usually when you're doing these in order, usually the not is done first. But let's take a look at this. So, and also, let me just say one more thing. Neither P nor Q means not P and not Q. So let's look at some tables relating to these. Not P is this table here. So let's say, for example, let's say if P is true, not P is false. If P is true, excuse me, if P is false, not P is true. So this not means just the opposite of what the proposition is. If P is true, not P is false. If P is false, not P is true, just the opposite. And then we have the conjunction. And let's set up a little table here. And technically, as long as you get all the combination, you can write these tables any way you want, but usually this is the form. Let's say if we have two propositions, we usually go true, 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 false, false, true, false, false. We usually do them like this. Again, it doesn't have to be as long as you get all the combination, but usually it's a little bit easier for someone else to follow if you're doing it in this way. Put the true, true first, the false, false last, and then do the true, true, false, then false, true, false, false. Start with the T's here, the F's here. Again, the true, 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 F, F, then TF, FT. Now the conjunction is going to be that and above. Remember when we had the Geneva is a college and in Beaver Falls. Remember we said the statement is going to be true if both are true. So like back up here when we did the and, Geneva is a college in Beaver Falls and, excuse me, Geneva is a college and it is in Beaver Falls. It's going to be true only if they're both true. Because if one is not true, the whole statement is false because we had that and there. So let's put that down. So if they're both true, then the and P and Q is going to be true. But if either one of them is false, the compound proposition can be false. If either one of them is false, compound proposition is false. If they're both false, it's going to be false. So if you have two statements and you're using and, the statements or the propositions are going to be true only if both of the individual propositions are true. Then we have the disjunction. That would be this up here. and set up the table in the same way. True, 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 false, false, true, false, false. And like I said, again, this is the or. And like I said, that really means and or. When you see or, it really means and or. You could have them both true. So once again, that would be the case. Say we had Geneva is a college or it is in Beaver Falls. We said because when you have an or, if either statement's true, the compound proposition is going to be true. So in this case, if one of them is true, if they're both true, it's certainly true. If the first is true, it's true. If the second is true, it's true. If neither is true, then that's the only time it's false. If both or statements are false. So those are the basic truth tables for not, conjunction, and disjunction. So now let's see if we can put this all together and do something a bit more extensive. Let's see if we can make a truth table for more compound statements using our basic statements here. So let me just show you what I mean here. Let's do this example. To create a truth table. For this. So let's go ahead and put this together. So our solution here. Again, make up your original P and Q. Be true, 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 false, false, true, false, false. And now let's see if we can construct this whole thing here. And before you, that doesn't really matter where you put in the table when you're evaluating this. Remember from what I said in the first page, usually this not is kind of evaluated first. Once again, it doesn't mean that has to be the very next column, but when you're putting things together, you kind of evaluate, like you'll evaluate the not before you apply this this disjunction. So again, let's do that first in any case. So we say we're going to need a not Q. So let's do this here. So remember, not is just the opposite of whatever the original was. So if this was true, this is false. This is false. This is true. This is true. This is false. False. This is true. And next, let's put this together. Remember, parentheses indicate you're going to kind of do this before you put this together with anything else. So let's put this together. Since we already know what P is, we know what not Q is. So let's put those two together. Let's go P and or not Q. Remember, this means similar to a union, similar again to and or. The statement is going to be true if P is true and or not Q is true. So we're going to be working with this column and this column. We can even, if it's helpful, you can even hide this one for a moment. just not to so you won't confuse the issue. So we're going with this and this. So again, remember this symbol is the or. So the statement would be true if either one of these are true. So you can just go down and see if there's true in either one of these, and the statement's going to be true. This one looks like it's going to be true. This one's going to be true. Now this one has neither one true, so that one's going to be false. And looks like this one's going to be true. Like that. So next, we're going to need this statement over here. Remember, once again, because these are in parentheses, we evaluate this before we put it together with anything else. So let's do this next. And once again, we're working with just P and Q. So once again, if it's not necessary, but you can hide this other stuff while you're evaluating that. And maybe make more messy than it should be, but let's do it this way. So again, remember this is an and. So remember this is going to be true only if both P and Q are true. So let's look. So it's going to be pretty easy to find that one is true. That one's got to be false. That's got to be false. That's got to be false. So we have that. So now the final thing we have to do is put these two statements together. Like this. And so what are we going to do here? We're going to be working with what this column and this column. And we're going to have an and or between the two. So again, we'll maybe cover those up just so don't get confused here. So let's put these two together. Remember with the and or, it's true if this is true and or that's true. We only need one of them true for the whole statement to be true. So this is going to be, that one's certainly true. That one's true. We have one of them true, that one's false. And that one is true. So we created the truth table for this statement here. So let's see if we can do it with, say, 3 propositions. And so let's do, again, follow the same kind of logic. So find the truth table for the statement here. Now we have 3 things, so we're going to have to make up a table with 3. Once again, there's kind of a way, now, not absolutely necessary to do it this way, but when you set up the original P, Q, and R, we'll usually do the 4 trues here, then the 4 falses, like this. So do 4 true, 4 falses. Then do exactly the way we had it previously. For this one, we'll do true, 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 false, false, true, false, false. So again, just like we had previously. So for the top one, do true, 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 false, false, true, false, false. And down here, true, 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 false, false, true, false, false. Like that. Once again, this isn't absolutely necessary to set up this way, but it helps if someone else is looking at your work. They're kind of used to this particular order. And so now let's start evaluating these things. So just like before, we see we're going to need a not Q. So let's put a column not Q. Remember, just look at whatever Q is and put the opposite. Once again, if it's helpful, you can cover up the columns you're not using at the moment so you don't get confused. I'm easily confused, so I'll do that. So this is false, false. Remember, we're just the opposite. True, true. False, false. True, true. And maybe you want to even make a few lines across here to keep things a bit organized. So now we're going to do P and not Q. So we're going to be working with these two columns. P, excuse me, P and or not Q. Remember, this is the or, which really is and or. So once again, if this is true and or that's true, it's going to be true. If they're both false, is the only time when this is going to be false. You can kind of see real quickly here. This is going to be true. 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 This is false, false, true, true, like that. So finally we have, remember we had to do this because it's in parentheses before we apply anything outside. So finally, we're going to put this one together with R. Like this. So again, once again, we're going to cover these up here. And keep in mind, we're going to put this together with this. This is the and or symbol. Once again, it's going to be true if this is true and or that's true. So once again, just look to see if there's at least one true. That's true, 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 true. Now this one, they're both false. True, true. So and there you have it. That's our truth table for this right here. That last column is our answer. The next thing we want to talk about are logically equivalent statements. Two statement forms. Are logically equivalent if and only if they have identical truth table. You know, if that last column is the same for two different statements. So let's just go ahead and go through this. Again, you could often do this just on one table. So let's do this. Determine if this statement are logically equivalent. Determine if this and this are logically equivalent. Now, it might be pretty obvious if you're doing, if you work with sets and things, they're going to be, but we'll take this simple case and just kind of use a truth table to determine if they are logically equivalent. The P, Q, R. Once again, if you set it up in the standard way, put all T's, 4 T's, and 4 F's, then then with these ones here, put true, 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 false, false, true, false, false. Same thing here, true, 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 false, false, true, false, false. And let's go ahead and go through these. Again, one P and Q and R. So we're going to need P and Q. And so, as we said previously, for that statement to be true, we need both P and Q to be true. So it's going to be true, true, false, false, because at least one of those were false. This is going to be false, 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 false. That. Then we'll put this together in a minute. You could put this together now if you wanted. It doesn't matter. What I'll do, I'm going to do this next one first. Q and R. And once again, Q and R. it has to be, it's going to be true only if they're both true. So we have true, false, 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 true, false, false, false. Once again, for some of these longer ones, we might want to put some lines here. This just to keep things organized a bit. So again, now we've made this now. Now let's put the two, write out the two statements. So let's do this one here. P, Q, R. Once again, I'm going to do this last. Now I could have done it, made the column over here. Doesn't really matter. I just sort of organized this way, but it's up to you how you want to do that. So again, let's put these two together. That's going to be this and this. Remember, they're going to be true only if they're both true. So this is going to be true. Let me just cover this up just to do this. So again, that's going to be, remember, we're comparing this to this, that to that. So it's going to be true only if they're both true. So it's false, 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 false. Then finally, we want to do this one here. And this is going to be, yeah, so this is going to be this one here. So which column are we going to use? We're going to use this one and P. I'll have to cover up a lot of things here. Again, you don't have to cover these up. Just more likely to mess up than you are. So I'm covering this up. And what we're doing, we're comparing this and this, these two columns here. And again, we have an and between them. So this is gonna be true only if they're both true. So once again, I'm gonna go true. And even maybe I cover this up so that's confusing. True, false, 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 false. So again, we're comparing these true, and they have an and between them. They're only going to be true if they're both true. And so we have this. Now, again, in this problem, we were asked to see if this statement and this statement are logically equivalent. So we'll look at the columns for the statement and this statement, see if they're exactly the same. They have to be exactly the same. So if we look at these two columns we're comparing, we're saying, is this the same as this? And so we have a true, true, false, 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 all the way through. You can see they're the same. They're same all the way through. So that means that means these two statements are logically equivalent because the truth tables are exactly the same. So again, if they had been not the same, if there's even just one entry that wasn't the same, let's say we had a true here and a false here, we would say they're not logically equivalent. Every single entry on the ones we're comparing, remember, just looking at this column and this column, the final, the ones that represent those, checking they're the same and they're logically equivalent. And so let's look at some other things. Again, here we're doing comparisons. Now, another thing we want to look at is to have like statements that are maybe always true or always false, no matter what the original propositions are. So let me see a tautology. Is a statement form that is always true. And maybe you might you can maybe think of some of the simplest ones would be something like this. Beaver Falls is a city. Or it is not a city. So when you think about that, that's going to always be true. Beaver Falls is a city or it's not a city. So if it is a city, it's true. If it's not a city, it's true because we have that or here. Again, like the truth table would be something like this. So your proposition is, say, Beaver Falls is a city. And then so if you made a truth table for this statement here, if you have P, and so you can have true, false. And of course, so the first one would be P, and then the second part of this would be not P. And of course, the opposite, that's going to be false, true. We have an or between these two. We have P and or, not P. So this is going to be, remember, the and or is going to be true if either one is true, true, true. So that's a way you could sort of logically say that statement is always going to be true. You don't even have to know what the answer is. You don't have to know if Beer Falls is a city or not. But the statement Beer Falls is a city or it is not a city, that's going to be always be true, based on logic, and then make it into truth table. Beer Falls is a city. Make that the statement. not that. And so you always get this. So in other words, if the final answer, if they're always true, again, that's called a tautology. Again, you don't even have to know what the answer is to this. You don't have to know whether beer falls city or not. You have tautology. Now let's do the other one. A contradiction is a statement form that is always false. So we could actually use for the same idea here. Beaver Falls is a city, and Beaver Falls is not a city. So we really said the same thing as the last statement, except in between the two propositions, we put an and instead of an or. So again, now this can't be both, can it? Beaver Falls cannot be a city. Excuse me, Beaver Falls uh, can't be a city and yet not a city. It can't be both of those. And that's pretty logical. Once again, you could put in the form of the truth table and again say Beaver Falls is a city. And then you can make a little truth table here. P, not P. Just like we did before. So we have a statement, Beaver Falls is a city, and Beaver Falls is not a city. And you could put these together, P and not P. Remember the and, for this to be true, they both have to be true. And you have false, false, like this. And so again, if your answer, if your columns are all false, then this is called a contradiction. Again, a contradiction is something that's always false, whether or not the original statements are true or false. Once again, so in this case here, Beaver Falls is a city, it's not a city. You don't even have to know whether it's a city or not to say that statement has to be false because of this. So once again, summary, a tautology is something that's always true. You don't have to know what the answer to these were. It's going to be always true. A contradiction is always false. So let's actually do this more extensively. Let's look at this statement. And now that we're understanding this a little bit better, uh, I'll go through this a little bit more quickly. Consider P, Q, not P, not Q. Once again, you could on some of these, if you have experience with sets or other chronology, you maybe look at this and sometimes know what the answer is. We're going to go through it formally with truth tables because often you're going to have the case where you're going to have to do that more formally for more extensive problems, one that you can't just logically look at and know what the answer is. So consider this is this a tautology, contradiction, or neither? So let's take a look at this. Do PQ, go in true, 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 false, false, true, false, false, like this. And so let's work with this here. Let's make up this one here. P or Q. So again, this is going to be true if one of these is true. Now let's do this one here. Well, we probably better do the not P and not Q first. We do not P. That's going to be false. False. True. True. And let's do the not Q. This is going to be false. True. False. True. This. And then we want to do this one here. Not P. Not Q. And put these two together. Remember, this has an and. So it's only going to be true if they're both true. This is to be false, 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 true. Then finally, the last one, we put these two together. Hopefully you can read that. I'm comparing the, let's see, excuse me. I'm going to cover this up again so we can see. I'm working with this one and this one, these two here. And so, again, there's an and between them. So it's going to be true only if this is true and this is true. So we can go down here and do, let's see, we're going to get what? False, 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 false. So again, the question was, is this a tautology, contradiction, or neither? If there had been a mixture of true and falses in this last column, you know, the one that represented this statement, if there had been a mixture of true and falses, or if there was just one of the opposite kind, it would have been neither. If they were all true, it'd be a tautology, but this one is all false. So this is a contradiction. So this statement is a contradiction, and we don't even have to know the truth of the individual propositions. We can say, yeah, this thing is a contradiction. It's going to be false. It's just not going to be true. And so what you could do, I won't go through this. You can show that P, Q, not P, not Q, is a tautology. And it would be good to practice. So this is for you to try on your own. Try this. And actually, you can probably see pretty quickly. We have all the parts already done over here, don't we? We have all the parts. And we have this because we have this column and this column. So if we covered these two up here and did this one and this one, remember, because we have an and or between them, it's going to be true if this is true or this is true. And let's go through this. Notice here we have a T, here we have a T, here we have a T, and here we have a T. So this last column here for this statement would have been all T's. This would have been a tautology. But it'd be good for your own practice to go ahead and do this. So now one other thing I want to mention is, again, we don't use this too much. Is the truth table for the exclusive or. You remember, we said that um, our or that we were using kind of means and or. And for what we're doing here, we're not going to use this too much. Sometimes for this symbol, they'll use like this symbol here for this exclusive or. Sometimes they'll use another symbol, maybe an X or to symbolize that. But what it means, this is going to be true. The exclusive or is true only if one of these is true, but not both. So, like, for example, this one is false because they're both true. The exclusive or means one or the other is true. Now, this one's true because one of them is true. This one's true, one of them is true. This one's false because they're both false. So for the exclusive or, so exclusive or is true only when exactly one is true. So if they're both true, it's false. If they're both false, it's false. When exactly. Yeah, we're not going to use this too much, but that's a good, it's something to keep in mind. Someday you may run across this.